So good evening everyone. Welcome to the session. The voice is clear for you, all of you? So good evening everyone. Welcome to the session. Okay. See, this is I think out of 4 different papers A, B, C, D, it is one. Maybe I think it is C. Maybe the question paper code. Which code it is? Question booklet code. Please check. What is the code, ma? This code? A2, na? Code of the paper. So the code of the paper is A2. Yeah. Right. See, I think I will discuss with you power system, analog electronics, digital electronics, and measuring instruments. These are the 4 topics I am going to give the clarifications on the questions available in our question paper. I think this is the booklet. I am using a A2 code. The code is A2. Yeah, Santosh, how you written exam? So see here, one question is this one, which is given under in the differentiating circuit given in the figure, function of R1 is to be. So what is the function of R1 is connected to be here? So usually if you don't have that resistance, you may have the capacitor like this, and this is the R. What is that one? R value. It acts like a differentiator. It acts like a differentiator. But because of the introducing this resistance, what it will do is it eliminates the high frequency noise. It eliminates the high frequency noise. So from the available options, it can eliminate the high frequency noise spikes. Noise spikes. Coming to the next question, the operational circuit. The operational circuit shown in the figure V0 is given by. See, where is the power supply given for this one? The power supply given to a this terminal, non-inverting terminal, and feedback resistance is connected for the inverting terminal. How it acts like? How it acts like? It acts like a non-inverting op amp. For the non-inverting op amp, what is V0 by Vin? Feedback factor V0 by Vin, the gain factor is 1 plus Rf by R1. This is already very simple question which we discussed in our class also. Rf by R1. So what is the 1 plus? What is the Rf? 2R. 2R divided by R. 2R divided by R. So this R gets cancelled, 1 plus 2, 3. So your output voltage is equal to 3 times the input voltage. Of course, here minus 2 Vs minus 3 Vs is wrong because it is not a inverting op amp. The option is available positive gain, positive output voltage. What is that we got? 3 Vs is the right answer. 3 Vs is the right answer for this. Right, right. Everything. Okay, clear about this one? It's a very simple question. Come to our my topics I am going to discuss. Remaining all the questions, some other teachers, faculty members from our SAIMEDHA, they will discuss. But my questions, power systems are nearly very more number of questions are given from the power system. I think highest percentage is there for power system topic. That too, whatever we discussed, 80% of questions are from, see here, see all of you. The function of a steel wire in an ACSR conductor. The function of a steel wire in ACSR conductor. It's a, how simple it is. I think not only SAIMEDHA students, everybody may write this answer also, because in ACSR conductor, center conductor is steel and outer layers may be aluminum. Steel is used for mechanical strength, provide additional mechanical strength. This one. No. It is not difficult. See, some topics, power system, electrical machines, measuring instruments, even digital electronics, some questions they given more easy, but in the signals and systems, control system questions also easy. Only difficulty in this question paper is, I think, that is signals and systems. Remaining all the questions, almost all, every topic, you can answer 70 to 75%. 70 to 75%. So this question is how simple it is. I think everybody will write this one. Now see here. What is this one? A three-phase transmission line. A three-phase transmission line. Its conductor at the corners of equilateral triangle of 3 side meter. The diameter of the each conductor is 1.63 centimeters. Better to take your paper. When I am explaining, better to take the paper. The inductance of the line per phase per kilometer is, that too inductance is given in the millihenries. The inductances are given in the millihenries. What is the formula for this one? What is the formula for this one? The formula for inductance, if symmetrically placed, equilateral triangle, one conductor is here, other conductor is here, other conductor is here, equilateral triangle having distance of d. What is the formula? 0.2 ln d by r dash. D by r dash. So this is millihenries per kilometer. Millihenries per kilometer. So 0.2 ln, how much d? What is the distance? 3 meters they given, 300 centimeters you can substitute like that. Divided by r dash means what? 0.7788 into r. R is nothing but radius. 1.63 diameter, 1.63 divided by 2 is the radius. So 0.788 into this one, logarithmic value of this one if you make and multiply with 0.2, I think you are going to get that 1.232 millihenries. Is it correct answer? Because calculator is allowed in the exam, scientific calculators are allowed. That's why these type of questions are given. Okay, all of you. Have you got the same answer? 0.2. Sometimes students may forget 0.7788. Sometimes unnecessarily square root of d1, d2, d3, something like that they will take, but you don't want to take because of it is symmetrical. Because of it is symmetrical. Next. This is a straightforward question, no difficulty here. Next. The transposition of transmission line is done to reduce corona losses, balance the line inductance, reduce the skin effect, reduce line losses. Even this question is given in the yesterday KPTCL JE question paper also. So transposition is always important to balance the line inductance. This is also a number of times I given this question in your practice examinations. All the questions what are available from the power system which are there in our question paper, you can check it even in our class discussion also. Even class discussion also, power system, machines, even digital electronics, how easy. Around 4 to 5 questions are given in the digital electronics. Now, coming to the, even for in the power electronics also, I think bidirectional, switch symbols, most of the questions are easy in the power electronics, isn't it not? In a high head power, high head low discharge, the water turbine is. I am not getting answers from you. Nobody is not answering. What is the answer for this? Silly questions you have to answer. Very, very simple questions these are. Okay, ma? So, high head means basically a Pelton wheel. Medium head is Francis. Low head is Kevlar. Very low head is propeller. High head is Pelton wheel. What is the turbine? Pelton wheel. Next. On which of the following cycle does a modern steam power plant works? When I start the thermal power station explanation, the first question or maybe second or third question I may ask you, what is the cycle used in the, even for joke purpose, I may answer like a Atlas or something like that. But the answer is Rankine cycle. What is the answer for this? Rankine cycle. Are you okay, ma? Everyone? Pelton wheel, and this one is the Rankine cycle. I hope. Next. See here. Oh, I think some students are telling paper is tough. I don't know. These are only match the following. So many information is available. Maybe little bit. Of course, if you to go for a 20 questions, maybe one or two questions may be difficult. But out of, in power system, nearly 20 questions are there. Out of that, at least you can answer 17 questions with the help of our classes and material. Yeah. See here. You can check it. Nuclear power station is base load. So many times I told you, diesel is a standby. For that one example I told, in cinema theater, when power fails, what the people will do? They start the generator. That's why standby. Standby. And gas turbine is a peak load. Both base load and peak load is a hydro. What is that? 1243. 1243. Answer D for this one. Yes, I told for JLM, but the thing is that now it is given in the AE exam. Yes, sir. Yes, so see, that student has remembered. Even ITA student is remembered this one. Yeah, very nice. Sriram. 40, 41, 42 JLM ki chepparu sir. Hydro is a both base load and peak load ma. Hydro is both base load and peak load. Next, see here. Matches we have to do. Moderator, control rod, coolant, shield. Shield means concrete shield. Shield is a concrete shield. Coolant is a sodium coolant. Where we are using this one? Sodium coolant is used in the fast breeder reactor. It is used in the fast breeder reactor. Next, moderator, which is a moderator. Graphite is a moderator. Control rods is the boron. Boron, cadmium, control rods. So we have to match like this. What would be the answer? 3, 1. What is this? This P belongs to what? 3. And Q belongs to 1. And R belongs to 4. And shield belongs to 2. 3, 1, 4, 2. 3, 1, 4, 2. Where is that? 3, 1, 4, 2. Option A. Right, ma. But you people are asking, sir, paper to be like this. But AEs are feeling difficult. I don't know how that is. So, for reducing the tower footing resistance, it is better to use ground rods and counterpoise. This is the option given in CL Vadva textbook, and some books they given chemical, ground rods and counterpoise. What the examiner given we don't know, but this is the question answer is available in the CL Vadva. Some other textbooks this one also given, but we want to see what the examiner is going to give. So this one next. In a high voltage DC transmission scheme, the reactive power is connected both for rectifier sending end and inverter receiving end. During the operation, such a DC links rectifier receives lagging reactive power and inverter supplies leading reactive power. Lagging reactive power and inverter supplies leading reactive power. So next, see here, this is the question. Given below two statements, one are labeled assertion and other one is labeled as reason. Assertion is glazing is done on the ceramic insulator. In the ceramic insulator, there is a smooth glazing is done to make the surface smooth and non-absorbent, without absorbing, non-hygroscopic. The material should be a non-hygroscopic. So that's why non-absorbing. This statement is right. Even you see what is that pin insulators made up of porcelain having smooth surface. Having smooth surface, that is called as glazing. Moisture from the atmosphere can be collected on the surface, discontinues on the ceramic and results the electrical breakdown. Suppose if you made with only ceramic without glazing, what happens? Rough surface will be there that will absorb the moisture. So this is the reason for this one actually. Both are right, and this reason is applicable for A, so that both A and R are true. R is the correct explanation for assertion. This is the right answer. Yeah, see here, match the followings. In the match the followings, bucko relay is for transformer, trans relay is for feeder, negative sequence relay is for electrical machines, directional overcurrent relay is only for long transmission lines. According to that, you have to choose the answer. Whatever is there for bucko relay, for these two, for this 1, for this 3, for this 4. 2, 1, 3, 4. 2, 1, 3, 4. This is the option available. Okay, okay. Right, ma. Next, here also match the followings. Braking capacity is a MVA. Low operating voltage is a air brake circuit breakers. High reliability and negligible maintenance. I think SF6. Some maintenance is there, not that much. Arc chute that will be there for air blast. Splitting is like that. According to that, you can choose the answer for this, whatever is available. Next. So, high and extra high voltages are adapted for transmission bulk power over long distances. Generally, if you want to transmit a large power, we can go for long transmission lines. So, extra high voltages adapted for a bulk power transmission over a long distances. The true power means active power transferred over a long line increases with increasing in sending end voltage. Exactly. Both assertions and reasons are matched together. This is both A and R are true. R is the correct explanation for A. Okay, ma? Right. See the next question. What would be the answer for this? Just a minute. అదే మన 2 కండక్టర్స్. అది కరెక్ట్. If you have, what is this one? Bundled conductor. What is the bundled conductor? We have to go for that. 2 into 10 power of minus 7 ln square root of m into n, m group to n group, m into n group, and we have to take the distances from this conductor to this conductor, from this conductor to this conductor, m into n divided by r dash. We have to use r dash into d, dsb. We have to take dsp whole root for this one, because of 2 set of conductors are there. All these values if you substitute, I think 0.89 millihenries per kilometer per phase. All the values you substitute, from here to here how much distance, from here to here how much distance, all the distances you take. This one is m group, this is n groups, m into n you can take. You, after simplification, we are going to get this one. Actually that is little more lengthy problem, may not be 1 mark question, but anyhow that may be 2 marks question. Actually such a type of questions will be consuming more time. This is the bus admittance matrix of a network shown in the figure, for which marked parameters are per unit impedances. Parameters are marked in per unit impedance, but they need a admittance matrix. So impedances you convert into admittance first, that is the duty. 1 by 0.1 10, and 1 by 0.2, what is this one? 5. This is the first node, this is the second node. 1 1 1 2 2 1 2 2. In the nodal analysis itself we will get the answer. It is not a power system also. 1 1 means all the admittances connected to the first node. 10 plus 5 15. Where is the 15? Only this one is the answer. That's it. You don't want to go for any other calculations. Even if you want to check, common for 1 and 2 minus 5 minus 5, common for 2 and 1 minus 5, common for only second node only 5 is there, 5 is the answer, like that. Muhammad Yusuf, out of 170 questions are right 5. You will get the job. No doubt. With that marks, you are going to get the job. It's a very good marks. Very good marks here. Very good marks. Okay, ma? Right? So the network is given. A simple power system network as shown in the figure. The reactances are marked per unit. Here also reactances are given. The value of Y22, capital Y22, you have to see here, capital Y22, not small Y22, capital Y22 of bus admittance matrix. Y22 they want to find. Y22 means what? This is the node 2. What are the admittances for this one? This is 10. This is 10. What is the admittance for this one? 5. What is the admittance for this one? 5. So totally 10. Y11 means minus J20. Minus J20. Because admittances are here. So option available is D. D is the correct answer. Yeah. Some ESC questions are repeated. Exactly. That I already told you number of times also. So this is the question from the networks. I think it is not appearing properly. Anyhow, this is 6 volts. I will write this one. 6 volts is here. 3 ohms is here. V0 is here. V0 plus and minus. This is 8 volts. And this is 3 V0. 3 V0. This one is 6 ohms. So apply KVL, you will get the answer. What is the KVL? Plus 6. This is plus and this is minus. 6. Plus 3 into I. 3 into I is equal to V0. 3 into I is equal to V0. Minus 8. Plus 3 into V0 means 3I. 9I. 9I. 3 into V0. V0 is nothing but I told you. I into 3. 3 into 3, 9I. Next, plus 6I. 6I is equal to 0. How much it becomes like? Totally 3, 12. How much? 15. This is 15 and 3. I think 18. 18 is equal to 2. 18I is equal to 2. I is equal to 1 by 9. I is equal to 1 by 9. 1 by 9 means approximate this one, 0.11. 1 by 10 is a 0.1. 1 by they are not asking 1 to 2. They asked only Y22. Y22 means all the admittances we have to connect. Now see here. A energy meter disk makes 10 revolutions. 10 revolutions in 100 seconds. When the load is 450 watts. When the load is 450 watts. Connected to the meter constant, energy meter constant. This problem I told in our class, in the measurements class. Number of revolutions per kilowatt hour. Number of revolutions per kilowatt hour. How many revolutions per kilowatt hour? So how many revolutions are given? 10 revolutions are given in 100 seconds. But we need in hour. So 10 revolutions in 100 seconds. 10 into 100 seconds. This is what we are going to get. But we require how many revolutions for 3600 seconds? Isn't it not? So if you make that one, I think 360 or something like that you are going. And this is for 450 kilowatts. For 1000 means we are going to get 800 revolutions per kilowatt hour. 800 revolutions per kilowatt hour. Here seconds are given, we want to convert this is into hours. 60 seconds is equal to 1 minute. 60 into 60 hours, that belongs to hour. Seconds are given. If you take the simple calculations, you are going to get 800 revolutions per kilo, whatever is the unit for that particular given meter. Now see here, it is belongs to the networks question. In a linear parallel RLC resonant circuit, linear parallel RLC resonant circuit, RLC parallel resonant circuit, which of the following statement is not correct? Linear parallel RLC circuit. When you have a resistance here, inductance here, and a capacitance here. Linear RLC circuit. RL and C. RL, linear RL and C. This is the circuit. RL in parallel to C. Then we have to see which of the following is not a correct. Not a correct, we have to find. Yeah, I told you number of times. Go through the previous IES and GATE questions while before entering into the exam of a KPTCL. Because I told you also number of times. Whenever if you are given connected like this, if connected like this, in a parallel resonant circuit, impedance is maximum. This is the right statement, but he is asking not correct. Next, power factor is unity. It is a right statement. Current is maximum. No, it is false. Current is minimum. Current is minimum. Current is minimum. What is the resonance frequency for a tank circuit? 1 by 2 pi root of 1 by LC minus R square by L square. This is the resonance frequency for this parallel tank circuit. This is also false. This is right. These two are the where it is available. 3 and 4 are available. 3 and 4 are available. Suppose if R, L, C, R is in parallel. If R, L and C is parallel, 1 by 2 pi root LC is also a right option, correct option, not correct option. But here they given in a linear RL and C resonant circuit. RL and C. This is a tank circuit. For tank circuit, resonance frequency formula is this one. That's why 3 and 4. RLC, if suppose RL and C, if they connected in parallel, this answer is also be the correct option, but question given RL and C, that's why we are choosing this. Yeah, see here, a network contains linear resistors and ideal voltage sources. The value of all the resistors are doubled, then the voltage across each resistor is. Whenever if you have an ideal voltage source is like this, whenever if you vary the resistance, voltage across this resistance does not change. Whatever voltage, if you have a 10 volts here, if it is a 1 ohm, 10 volts, if it is a 10 ohms, same voltage, not a practical voltage source, ideal voltage source. That's why the voltage will not be changes. Voltage will not changes. Are you okay, ma? Still, if you have any doubt, you can send in our WhatsApp number. Any modifications are there, we will give the clarification for that. Otherwise, we will modify our answers. But this belongs to the coil, a coil of resistance and inductance. R and L respectively is connected in parallel with a 100 microfarad capacitor. The frequency at which the circuit behaves like a non-inductive resistance. The same question yesterday, this question is given in the KPTCL JE exam. Same question. I think 2 questions are repeated from my topic. In the machines, I don't know. From the power system, 1 question on networks, transposition of the transmission lines and resonance frequency, because both the question papers are given by the KEA. That may be one reason, because numericals are also not changed. The teachers, what they will give almost same. Psychology, F naught is equal to 1 by 2 pi root of 1 by LC minus R square by L square. R square by L square. So if you substitute these values, 1 by 2 pi root of 1 by how much L? 0.2 into C is 100 microfarads, 100 into 10 power of minus 6 minus R square. R is how much? 20 square divided by L square, 0.2 whole square. All these things if you substitute, 31.83 hertz. Yeah, exactly. 31.83 hertz. These are all belongs to electrical machines. Mainly they will give more weightage for electrical machines and power system usually. See here, in the transistor shown below, the collector to ground voltage is plus 20 volts. Plus 20 volts. This is the collector point. This point is the collector point. We need to get the voltage VC, which is equal to 20 volts. Whatever the voltage is available here, the entire voltage has to appear across this. Entire voltage has to appear across this one. So it means only possibility is between this one we want to make the open circuit. If you make open circuit, then drop across this one. IC becomes 0. IC becomes 0 and drop across this one 0. The 20 volts will be available here. 20 volts is available here. See here, collector to emitter terminals are shorted. Suppose if you short collector to emitter, what is the potential? What is the voltage across short circuit? 0. Voltage across short circuit is 0, but we require 20 volts here. Keep it in mind. Are you got it? Because voltage across the short circuit you never get. Next, emitter to ground connection is open. Yeah, this is open. Here is open. Whenever open means what happened? Emitter current is 0, collector current is 0. The voltage, it acts like a open circuit. You are going to get 20 volts. Even though we will check the answers, 10 kilo ohm resistance open. Whenever if 10 kilo ohms resistance is open like this, it is open. What happened? The collector current may be open, but voltage is available these 2 points. Voltage, because voltage across the open is available. We need voltage across this one, not across this one. If you open this one, what happened? The entire voltage is available here, not here. Are you got it? So this is also be the not answer. Collector to base is shorted. How? When you short this one, you don't get it. So only possibility emitter to ground connection is to be open. Because we want to make the collector junction is to be the open circuit voltage has to get, for that this condition is satisfied. This condition is satisfied. Next, this is the question given from the digital electronics. The output of a logic gate. The output of a logic gate is 1 when all the inputs are logic 0. That gate is either, see, whenever, if OR gate is available, if all the inputs are 0, logics are 0, output we don't get 1 in a OR gate. A plus B plus C. If all the inputs are 0, 0 plus 0 plus 0 something, how can you get 1? No, you never get. This option is invalid. And coming to the AND gate and AND gate, what is that? A into B into C, 0 into 0 into 0. How can you get? You don't get 1. So this option is also wrong. But in the NAND gate, what happened? In the NAND gate, what is the NAND gate? Suppose if you come to the XOR gate, if you come to the XOR gate, A, B, 0, 0, 0, 1, 1, 0, 1, 1. When 0, 0 is given, what is the output of XOR gate? 0. And 1, 1 is given, 0. When all the inputs are 0, output we are not getting 1 in a XOR gate. This condition is not satisfied. In the case of NOR gate, so if all are 0, 0 plus 0 plus 0 whole bar, it becomes 1. And in XOR gate 0, 0 is given, you will get 1 here. That's why option B is the right answer. Are you clear, ma? How we chosen this one? Right, all of you? Because in XOR gate, if all the inputs are 0, 0, output you are getting 0. But we need a 1. We need a 1 for this. That is possible in XOR gate. Now, see, in the K map, in the Karnaugh map, maximized expression. It is not maximized expression. They have to give minimal expression. Minimized expression they have to specify. Minimized expression, the K map, X is the don't care. Okay, such information is available. What we will make? We can make a one quad like this, because you can take don't care as a support, and you can take this is as a one quad like this. One quad like this. What are available common for this one quad? What is available here? What is this one? CD. This is CD bar. CD and CD bar. What is this one? What is available here? In this case, A bar, B bar, A bar, B, AB and AB bar. AB bar. What is common for this quad? So here B bar is there, here B bar is there, which is common. C is there, C is there. CB bar is one option. CB bar is one option. CB bar. What are that? CB bar is available here. CB bar is available here. CB bar is available here. So this option we can eliminate from our options. Next, what is this for this quad? What is for this quad? What is common? What is common here? C bar, D bar, C bar, D. For this quad, what is common? C bar is common, B is common. So C bar B is available here. C bar B is available here. C bar B is available here. All are available. So then what we have to check? Again, here is AB is available. Here AC is available. Here CD is available. That only we have to check. AB means what? You require. AB means where is that? AB means all four should be required. Can you make this is a one quad? Of course it is possible. That may not be more appropriate. That may not be, because this one is available now already. One is available here. And coming to the AC. AC means what? A and C. A and C. A is here. A is here, C is here. All are don't cares, no original term. And the last one CD, if you see, C and D. So this one we have to remove. For that we can make one quad like this. One original term is required. With this original term we can do it. So that answer is CD. Option D is the right answer. This is very simple question. I told you for my students, the digital electronics questions also easy means they said only 2, but questions are 5. In the digital electronics questions are 5. Even in the networks questions also very simple. Resonance frequency, simple loop current. How can you say the paper is tough? I don't know. Power system is easy, machines are easy, networks are easy, measuring instruments are easy, digital is easy. Maybe signals and systems you may not have familiar with that. Control system questions also I think. Now, what is this one ma? See here. What is this one? This is Nand Gate, AB bar. This is Nand Gate, BC bar. What is this one? A bar. What is this one? C bar. So, what is this OR gate? AB bar plus BC bar plus A bar plus B bar. Not B bar, C bar. This one, C bar. Now, what you will do here? A bar plus B bar plus B bar plus C bar plus A bar plus C bar. C bar. So, A bar, B bar, C bar. A bar plus B bar plus C bar, which is very simple question. This is the right answer. Okay, ma? Right, Chana? All of you following? Next. So, see here. Two-way switch can be implemented by using logic gate. Two-way switch means it is a staircase switch. One switch is in a down position, other switch is in a up position, light will glow. That is called staircase switch. This is the question given already for the gate exam for electrical engineering students itself. So, two alternatives are required, the bulb will glow. 1, 0, output is 1. 0, 1, output is 1. In that condition, our bulb will glow. When both the switches are 0, 0, both the switches are 1, 1, our bulb will not glow. That's why this condition will satisfied for what gate? XOR gate. This is a staircase switch. Right, ma? For this, many students are responding. Next. See here, TP is the pulse width. Pulse width means this one like this. Delta T is the propagation delay. Delta T is the propagation delay. TPD can be written as delta. T is the period of pulse train. T is the pulse train. Which of the following condition to avoid race around condition? Whenever your pulse width time is much greater, the race around condition has to be dominate. If you want to reduce the race around condition, we are like using a edge trigger or something like that. We want to reduce the pulse type. Which is a pulse type? Pulse width is a TP. TP should be less. TP should be less. Only this condition is satisfying. Remaining all are TP is high, TP high, TP high. This is only the condition will satisfy. TP must be less than the period of pulse time and as well as the propagation delay. This one, this condition will avoid the race around condition. The race around condition. So, if the drain voltage in N MOSFET is negative when it is operating in, actually whenever drain voltage, suppose this is your MOSFET is here, if it is a source, when it is operated with a minus voltage, it will be operating in a inactive mode. That will not operate in an active region or ohmic region. It acts like an inactive region. For this, lot of explanation is required. but directly I am giving answer. In regular classes, I am going to explain if it is required. These are all related to my topics. Remaining all the questions other teachers will discuss, and Sekar will handle remaining topics: power system, digital, analog electronics, measuring instruments. These are the four topics I discussed, four subjects I discussed. Electrical machines and remaining topics other teachers are going to take. Okay, ma? All the best, my dear students. The sir will take, Rajshekhar sir will take the next session. Okay.
Hi guys, how is the day? So now our Sampath sir will come to explain power electronics as well as control systems. In power electronics and control system also they given you maximum questions. So now Sampath sir will come to explain power electronics as well as the control systems. Then after I will come to end the session with electrical machines. Okay sir. So please welcome our sir, Sampath sir.
So good evening everyone. So I am going to discuss the power electronics as well as control systems. So first we are going to see with the from question number 1 onwards. So the power efficiency of a switching voltage regulator is much higher than that of a linear regulator because so most of the time in case of our power electronics we always operate power semiconductor devices as a switches. So definitely so in order to increase the power efficiency of a switching voltage regulator, so must and should be it acts as a switch. So in order to operate means in order to increase the much higher than that of the linear regulator means the power efficiency. So the main thing is the power electronic devices operate as a switches. So next one is which of the following transfer function of second order linear time invariant systems represent under damping condition. So you need to know the minimum basic of damping ratio zeta. If zeta equals to 1, critically damped. If zeta is greater than 1, then become over damped. So zeta less than 1 means under damping condition. So we need to find out the out of all the four transfer function. So which of them are having the zeta value is less than 1. So try to check here. S square plus 2 zeta, it is looks like S square plus 2 zeta omega ns plus omega n square. From here omega n will be, if you compare these two equations, omega n will be 2, 2 zeta omega n equals to 3, which means that zeta value from here, if you substitute omega n here, you will get zeta value is 3 by 4, which is less than 1. So option D will be the answer for this question for under damping condition. Next one. So what will be the closed loop transfer function of a unity feedback control system? So unity feedback control system is given. So find the whose step response is given. So C of t. So first you need to understand this is a second order system. So for a unit step input, so it is similar to 1 minus e to the power of minus zeta omega n t into sine of omega d into t plus phi, omega d into t plus phi. If you compare this equation with that expression, so you will get zeta omega n equals to 8, zeta omega n equal to 8. You will get omega d equal to 6. So omega d can be written as omega n into square root over 1 minus zeta square, that equal to 6. If you bring this omega n to the inside, that will become square root omega n square minus of this will be zeta omega n whole square, that equal to 6. So we already know the zeta omega n value is 8. So you will get omega n will be equals to 10. If you substitute in this equation, you will get omega n is 10. If you substitute omega n equal to 10 here, you will get a damping ratio is 0.8. So if you know the damping ratio, if you know the natural frequency of omega n, you need to find out the transfer function. So second order transfer function is k into omega n square divided by s square plus 2 zeta omega ns plus omega n square. So this is the formula. So omega n you already know, 10. 10 square means 100. So answer will be A for this question. So answer is A. Next one is 22nd. So in this 22nd question, you need to send the, see here in this first or whenever if you are transferring to the primary side or you are transferring the secondary side, you need to divide or multiply the equation. That is the only thing you need to observe here. So here y value is nothing is there, only you need to get the gain value is 1. So try to check wherever gain you will get 1, that will be the answer. So see here. So for the C, if R is 1 value, if you multiply Z into 1 by Z, you will get 1 for output value of Y. So that's why answer will be C for this question. Next one. So any unity feedback control system, you need to find out the range of K. So you need to find out the range of K for a stable system. In order to make the system stable, you need to find out the range of k. For the range of k, first we need to find 1 plus g of s into h of s equal to 0. So if you multiply that, you will get s square plus 13 s cube plus 13s square plus 30s plus k equal to 0. This is the equation you will get. Just convert 1 plus g of s into h of s equal to 0. If you translate it, you will get the total characteristic equation. So first one is s cube 1 30. Next one is s square 13. Next one is k here. S to the power of 1 is 390 minus k divided by 13. Next one is s to the power of 0 where k. So here they mention here system is stable. Whenever system is stable means there should not be any sign changes in the column of the matrix, which means that the s power 1 row must and should be greater than 0 and k must and should be greater than 0. So which means that 390 minus k by 13 greater than 0. If I transfer this k minus 390, that will become less than 0, which means I just multiplied with a negative sign to this equation. I just multiplied with a negative sign with this equation. That will be k minus 390 less than 0, which means that here 0 less than k less than 390. So answer will be A for this question. So for the 24th question, 0, the range of k is lies between 0 to 390, then system becomes stable. Next one is, so here in the Nyquist plot, negative real axis at a distance of 0.4, then you need to find out the gain margin of the system. Here you need to find out the gain margin of the system. So gain margin of the system equal to nothing but 1 by magnitude of the distance, nothing but 0.4. You will get 10 divided by 4, nothing but 2.5. So gain margin of the system of the Nyquist root locus is 2.5. So answer will be D for this question for the 25th one. Next, transfer function of the system. Here we need to find out the transfer function. So first you need to identify how many forward paths are there. After that, you need to identify how many closed loops are present in the circuit. So what is the forward path gain? Forward path gain is Z1 into Z2 divided by 1 minus of, you need to find out the sum of individual loop gains. What is the sum of individual loop gains? This is the first loop gain. This is the second loop gain. So minus Z1H1 minus Z2H2. Next one is plus, which are non-touching, product of the two non-touching loop gains. These two loops are not touching each other. So that's why I am multiplying these two, Z1 H1 into Z2 H2. So answer will be D for this question, 26th one. So G1 into G2 by 1 plus G1H1 plus G2H2 plus G1H1 into G2H2. So answer will be D for 26th question. Next one. So this is a little bit tricky. Most of the time they will ask number of roots in the right half of the S plane. So directly we will choose either 1 or 2 or 3. But here they asked number of roots in the left half of the S plane they asked. So first S cube. S cube means 1. S to the power of 1 is 9. Next one is S square is 6. S to the power of 0 is 4. Next one, s to the power of 1 is 6 into 9 minus means 54 minus 4 divided by 6. S to the power of 0 is directly 4. So there is no sign changes happened in the first column of the matrix. Whenever no sign changes happen, number of roots present in the right half of S plane is 0. So all the roots are present in left half of the S plane. So left half of the S plane, how many roots are present? 3 roots are present. So answer will be A. So number of roots present in the left half of the S plane is 3. So answer for 27th question is 3. So this is a power electronics, power semiconductor devices questions. So see here, first one is diode is given, thyristor is given. So first we need to find out the quadrant of operation. So I already explained in the class, this is a plus I, plus V and minus V. So voltage is related to blocking, current is related to direction of a current. So this diode allow only which current? Only allows the positive current. It cannot allow the negative current, which means that current allowed is positive. So if I apply the positive voltage, I need to find out the here voltage is blocking voltage I need to find out. So if I apply the positive voltage, then diode will on. So but if I apply negative voltage, diode will block, which means that diode operation is in the second quadrant. When it comes to thyristor, it will block the positive voltage, negative voltage. At the same time, it allows the current only in one direction. So that direction is a positive current. So region of operation in the first and second quadrant. Next one. So for the BJT circuit, whenever if you are connecting the diode parallel to it, which means that it allows the positive current, it allows the negative current, which means the operation of the device is first and fourth quadrant. So operation of the device is in the first and fourth quadrant. So try to check the answer. Answer will be for the 28th question. It is C. So answer is C for the 28th question. Next one, 29th question. So see here, three-phase bridge inverters are given. So operating conduction angle is 180-degree mode of operation. So the sequence of SCR conduction, first two steps beginning with the initiation of thyristor 1. So they are initiating with thyristor 1. So this is a thyristor 1 for the first positive half cycle. Next thyristor will be 6. After that 5, which means that operation is 5, 6, 1. Next one, after 5 you will get 6, after 6 you will get 1, after 1 you will get 2. The operation means the cyclic process will continue. 6 means again you will get 1, 1 means 2, 2 means the next cycle is 3. So this is the region of means the thyristors are going to operate like this 561 612. So option will be D for this question. Why? Because these are the thyristors are operating region. So next question is voltage commutated chopper is given for the question number 13. So here voltage commutated chopper is given. Operating frequency is 1 kilohertz and the load current is assumed to be constant, which is 10 amperes. Find the minimum time which is required in microseconds for the main thyristor to be turned on. So we need to turn on the main thyristor. They are only asking the turn on time of the main thyristor. Whenever they are asking the turn off time of main thyristor, here they need to mention the actually capacitor should be charged to fully voltage, which is nothing but it should be charged to plus 250 volts. Then only the process will continue. So turn on time of the SCR is nothing but pi root LC. So pi into square root. L value is 2 into 10 to the power of minus 3 into capacitance is given as 1 into 10 to the power of minus 6. So if you multiply this, you will get the answer approximately 140.4156 something you will get. So answer is approximation is 140. So next question is so 31st question, when diode is connected with anti-parallel with the thyristor, then so whenever diode is connected, just a second guys. So whenever diode is connected anti-parallel with the thyristor, so whenever if you are connecting diode in anti-parallel with the thyristor, then turn off time will become decreases. Why? Because it is connected in the negative period. So turn off power loss will be increases. So option will be B for this question. So next one, 32nd, during forward blocking state. So they are just asking the forward blocking state of the thyristor. So forward blocking state means this is the thyristor. Forward blocking state means here I am giving positive and negative. Whenever you are giving positive and negative to the thyristor during forward blocking state, so whatever the junction J2 is will be open circuited, whereas junction J1 and J3 are forward bias. But when junction J2 is open circuited, whatever the applied voltage that will applied across the junction J2, which means large voltage, but it is open circuited means there will not be flow of current. So current flow moment will be low current. So answer is B for 32nd question. Next one, 33rd. So here BJT is series with the diode. Whenever BJT is connected in series with the diode, so which will normally, if you know that operation of BJT will be in the first quadrant, but whenever you are connecting the diode, it will block the negative voltage too. So operation will be in the first and second quadrant, which means that option C will be correct for this question. So next one, 34th question. So normally while I am explaining the chopper circuit, I explained like buck chopper, boost chopper and buck boost chopper. In all the three cases, I mentioned over there inductor. Whenever inductor is connected across the load circuit, that acts as a buck chopper. When inductor is connected in series with the source, it acts as a boost chopper. When inductor is connected to the ground, then it acts as a buck boost chopper. So these are the three choppers I explained, which means that whenever large value of inductance connected in the circuit, there will not be any change in the output current, nothing but the average value of the load current. There will not be any changes will happen. So that's why we are connecting a large value of inductance in all the three circuits. That's why output current is remains constant. Next one. So the remaining questions will be explained by the Rajshekhar sir. Okay guys.
Okay, guys. Are you ready, guys? Yes. Let's see from the first. So what are the remaining questions? If those are the my questions, I will give you the explanation. Any other questions, just I will give you the key, because signal science systems and EMF faculties are not available, because of not available. That's why. That's why. So I will start from first question, second question, and third question. Now I have to explain, I have to give the answer for third question. Actually, this is from microcontrollers and even from microcontrollers and microprocessors. The answer for this question is option A, sir. The answer for this question is option A. You will get option A by pop-up 2 times increased. That's why if you do this, you will get the answer. Hi to everyone. Hi guys. Nice to see you here again. Yes. So this is option A, sir. This is from microcontrollers and microprocessors. The third one, and the fifth one. And fifth one, what is the fourth one? The fourth one also from the microcontrollers. The answer for fourth one also option A, sir. The answer for fourth one also option A. This is also from microcontrollers. Actually, sir was not available now. And fourth, the next fifth one, this is from signals and systems. And its answer is B. The fifth one, the answer is B. Yeah, Mamta. Yes. So I will send you the solutions for this. I will WhatsApp you in your groups. But just now see what are the answers. Then after I will post you what are the solutions belongs to this. Right? And fifth one, the next sixth one also belongs to the controls. Its answer is option D. The sixth one answer is option D. And the seventh one answer is from the microcontrollers. I think this is very important, sir. Sir covered already. In your notes you can find this is very important. 2 machine cycles. This is repeated question previously also. The seventh one is option B. Eighth one already sir explained. Ninth completed. 10th one from the signals and systems. And its answer is C. Frequency sampling, yes. From the signals and systems, answer is C. And the 11th one also signals and systems. Its answer also C. 11th one also answer C is the correct answer. Next 12th one also from the signals and systems. And 12th one answer is the D, sir. 12th one answer is D. The 12th answer is D. And 12th D. Next 13th also, 14th also from the signals and systems. The 13th answer B and 14th answer is the D. I will send you these solutions. Telugu medium will start, Nana, mostly within 2 days. 2 days lo start chestam, Nana. 14th one. Next 15th and 16th also from the signals and systems again. Around 10 questions came from signals and systems. Most of the questions from the notes only. And our Kankayas are also taken many classes for you for question for practice like that. Maximum questions came from the signals and systems really. 15th B. The 15th answer is the B. And what about 16th? And 16th answer is the D, and 17th answer is the A. 16th answer is the D, and 17th answer is A. 17th answer is A. And 18th answer is D. 18th answer is D. This is also signals and systems. This is also signals and systems. So really around 10 questions are came from the signals and systems. Yes. Okay. I will give you, sir. I will give you everything about cutoff like that. We can discuss. And let's see this question, sir. Once this is from EMF. Generally, this is not only from EMF. You can get the answer from like electrostatics. Very easy question. This question I given for the diploma junior engineers also. Generally, you know very well the force between 2-point charges. The force between 2-point charges is inversely proportional to distance square. Yes or no, guys? The inversely proportional to, this is Q1, Q2. The distance is, for example, D. This is directly proportional to Q1, Q2. Inversely proportional to distance square. If the distance increases, the force between those 2-point charges will decrease. If the distance decreases, the force will increase. It's a very easy question. What they given? Positive and negative charges are initially 50 millimeters apart. When they are moved close together, nothing but the distance decreased, hence the force will increase. Here, close together, they are now at 10 meters apart, 10 millimeters apart. Nothing but the distance reduced 5 times. Yes. When the distance reduced 5 times, this is a square formula. This is square formula. When the distance reduced, the force will increase square times. So what is the answer? 25 times. Don't make a calculations here. We discussed many questions like a square formulas, right? When the distance reduced by 5 times, the force increased by 25 times because of square. So where is the answer? 5 times, 10 times, 25 times larger than actual value. This is really very good. See, if you go through the question clearly, you will get the answer immediately, guys. Immediately you can get the answer. Yes, guys. Next one, 19th questions are already given. And this is also from EMF. This is also from electromagnetic fields. So which of the following is not the correct answer? Not Maxwell equations. Wherever you go, sir, for electrical people, Maxwell equations is the question. 100% they will ask you questions. Even our sir also given you. Right? So which of the following is the wrong answer? The 21st question. Can you tell me which of the following is the wrong answer, sir? 100%. This is not a correct answer. Del J is not equals to this minus dou rho by dou T. Simply, if you know the Maxwell equations, you will get the answer directly. You can get the answer directly. Right? So let's control systems. Really, control systems questions are very easy, sir. Very easy. Even though you don't know about that, you can get the answers. See, this is not a hard question paper, sir. This is a moderate. If you have a good command on the all questions, generally basic command, sir, no need of extraordinary performance to this. But the thing is that you have to go through the question carefully. Then you have to understand the question. You will get the answer within seconds if you know if you understand the question. Really, even our control systems are given that. You people said that he is an excellent faculty. Yes or no? Actually, the sir given you very well. Sir also felt very happy. Yeah, very easy questions came from my subject, sir, like that. Okay. So, yes, Ramesh, very good, guys. That is Poisson's equation, right? Right, sir. Actually, I am not much content on the EMF. Okay. So next, what is next? This is also from EMF. So can you tell me, sir, which of the following is the correct answer? Can you tell me, sir? So let's see here, 2 zeros are there. So they given the answers like this. So which is appropriate? Here 4 and 4 is there. 2 and 2 is there. 4 and 2, what, sir? Once see here, 4 and 2 for P and S. For P and S, they given 4 and 2. Remaining 2 are the zeros. Actually, these 2 are the zeros. Nothing but remaining 2 options belongs to 0. So we can get the answers directly from this. 3110. How you can get both are the zeros? So actually, here these 2 are the correct answers, sir. These 2 are the correct answers, sir. These 2 are the correct answers. So they given like a question here. So where is my machines questions, sir? Just wait for a few minutes, guys. Our machines questions will come. Our machines questions will come. All our control systems, power electronics, power systems, turn off. This is also already completed. This is also already completed. Already completed. Already completed. What is this question? Yeah, our questions came, guys. Machines questions came, guys. Let's see now. Let's see now. So, cogging in induction motor occurs when? Actually, I told you in the class, 100% they will ask you question from cogging and crawling. 101% wherever you go. So from that, generally how we can eliminate the hunting, nothing but the number of slots in the rotor should not be equals to number of slots in the stator, number of slots in the stator, then we can avoid the cogging. As well as by skewing also we can avoid the cogging. So to avoid the cogging, the number of slots in the rotor should not be equals to number of slots in the stator. Even once remember that I given you like a diagram also. I explained you clearly. If the number of slots in the rotor and stator are same, then the magnetic locking will be takes place. That is called cogging. I given you a once remember. I think everyone imagined this diagram in your exam. Yes. So when the number of slots in the rotor is equals to number of slots in the rotor is nothing but if you went like this, both are equal. At this condition, the cogging will be takes place. If both are equal, nothing but if you, this is minus, if you send here both are equal, then the cogging will be takes place. Really very easy question. Yes, very good, Ramesh. Very good. Very good. What about remaining people? Give the response, guys, everyone. Give the response. Right, sir. Let's go for next question. Yeah, this is really different question. This is really different question. What they asked here? What they asked here? Yes, what they asked here. Once see a inverter capable of supplying a balanced three-phase variable voltage, variable frequency output is feeding three-phase induction motor for 50 Hz and 440 volts. The stator winding resistance and the motor are negligibly small. They neglected the resistance. During the starting, the current, inrush current can be avoided. What we have to avoid? We have to avoid the inrush current or starting current. Inrush current and starting current without sacrificing the starting torque. The starting torque should not be reduced, but we have to avoid the magnetic, what is that, starting high currents, which are called inrush currents. So how we can avoid, sir? Low voltage at a rated frequency, low voltage keeping V by F ratio constant. Yeah, this is really good. V by F ratio we have to maintain constant, and if the voltage is very less, then we can avoid the inrush currents. If the voltage is more currents will be there. If the voltage is less currents will be there. So next, rated voltage low frequency, no. Rated voltage, no. So which of the following is the appropriate, sir? Just by thinking the concept you can get the answer. Very good, Ramesh. Very good, very good. So this is the correct answer in 36 and in 37 and in 37. This is also somewhat different question actually. What is this? A three-phase induction motor. Drive is fed from a variable frequency, variable voltage source such that air gap flux is constant. We have to maintain V by F constant. Air gap flux is constant, nothing but V by F constant. Which one of the following is the correct? The armature current of the motor is Three-phase induction motor. Drive is fed from a variable supply and variable voltage source. The air gap is constant. The armature current of the motor is. Where is armature in induction machine? Yes or no? This is a three-phase induction machine. Where is my armature? They has to ask the question like the stator current. The stator current of the motor is like that. They has to ask. Otherwise, the rotor current is. But here, if you take the stator current, generally the stator current, even though depends on the rotor, in the equivalent circuit, we can say that. So here, this is independent of stator frequency, but depends on the rotor frequency, because the rotor frequency will decide the reactance in the rotor. That will decide the current in the stator, like that. So actually, this is armature current. It's a blunder. But if we want to choose the correct answer, I think from my knowledge, according to my knowledge, I am giving you the option B is the correct answer. Option B is the correct answer. Yes. Independent of rotor frequency, but depends on stator frequency. That is not matched, Ramesh. Okay. Okay. So let's see. This is the option B. And what about next? Where is my questions, sir? This is power systems. This is power systems, etc. Power systems again. Power systems again. HVDC. HVDC. This is also completed. This is also completed. This is also completed. Power systems again. Again power systems. Again power system. Power systems questions also good. Nice. Networks. Very easy questions. Yeah. Now here we have our electrical machines questions. Here we have our electrical machines questions. I think this is not clear. This is not clear. So the question is that. What is the question, sir? A 200 volts DC shunt motor has an armature resistance of 0.2 ohms. They given armature resistance and voltage they given, and field resistance of 100 ohms. Field resistance of 100 ohms. It draws a current of 10 amperes from the supply. Nothing but the line current they given. The line current they given 10 amperes. The generated EMF of the generated EMF in the armature neglecting the brush EMF. Generated EMF nothing but here we have to take back EMF, sir. Don't calculate EG. Okay. What is the EMF generated in the motor? That is called back EMF only, sir. EG is equals to V minus IARA. You know very well. V is the supply voltage 200 minus RA is the 0.2. We know that they given. What is armature current? In the motor, the armature current is here the line current. From that, something will be goes to the armature, something will be goes to the field. So the armature current nothing but whatever the line current is there, line current minus the field current. What is the field current? ISH is equals to V upon RSH, 200 upon 100. 200 upon 100 nothing but 2 amperes. Here 10 amperes current, out of 10 amperes 2 amperes per field. So for armature 8 amperes will come. So 8 of 0.2, 8 of 0.2, 1.6, right? Yes or no? 1.6, right? So 200 minus 1.6, 200 minus 1.6, 198.4 volts. Yes or no, guys? Yes or no? So 198.4 volts is the correct answer. This is really very easy question. This is really very easy question. In our electrical machines again. Yeah, this is our question. Guys, have you remember this question? We explained in our class, and I given you few questions, around 10 or 12 questions from synchronous machine. I told you surely questions will repeat from this. Exactly with numericals. Actually, this is a previously question, sir. Exactly with numericals, you got the same question. Once go through your question papers, what I sent you for synchronous machine. From that, this is the question. You can get the answer easily. The voltage drop, generally here the voltage drop here is IZ ISC into ZSC. What is I? Here they given what is the current, line current, not ISC, the line current, whatever the load current into ZSC. Whatever the load current they given 200 amperes, and you know very well ZSC, EOC upon ISC. What is EOC? 200 volts is the EOC and 400 amperes is the ISC. 200 volts is the EOC, 400 amperes on the ISC. So this is 5. The ZSC is 5. 200 multiplied with 5. 200 multiplied with 5. Very good, Sai Prithvi. Yes, this is the 1000 volts. This is the 1000 volts. Yeah, this is very easy question and repeated question with numericals. Yeah, this is the question they given from the brake test in the DC machines. Brake test from the DC machines. So what they asked, sir, in a brake test, the shunt motor, the speed they given, the load on side of the brake band is 28.9 newtons and the other is 1.67 newtons. S1, S2, they given S1 and S2. They given S1 and S2 like that. If the diameter of the pulley is the diameter they given 15.2 centimeters, we have to convert into meters. The output, what is the output? Output P is equals to 2 pi nt upon 60. N they given 1500. Torque nothing but force into radius. The force nothing but they already given in terms of newtons. The difference of these two, what is the difference of these two? 1.67, 28.9, 28.9 minus 1.67 multiplied with radius nothing but 15.2 centimeters, right? That is the diameter. What is the radius? 7.6 centimeters. That's why we have to convert into meters by 100. This is the torque. If you substitute here, you will get the answer that 325 watts. You have a calculator, you can get easily this answer. So really this is also a very easy question. If you have this formula, you can get the answer easily. Even in our brake test, I given you these formulas, but I didn't expected this numerical question from this. But it's very easy question. Yes, guys? Yes? Let's go for next. Let's go for next. Yeah. This is the question they given to confuse you people. But you are Zems, right? You won't get any confusions, right? Let's see what they asked. So we have to match these two. First of all, let's see here. This is C here. This is C here. This is the long shunt generator or motor, whatever. Long shunt. This is a long shunt generator. They given G. Because this shunt winding is connected in parallel to both. And whereas this is also long shunt. This is also long shunt because these two are in series and this parallel combination is across both. So these two are the long shunt. That's enough, sir, actually. Actually, once go to these options, Q and R long shunt. Where is long shunt? 3 and 2, 2 and 3, Q and R, 2 and 3, only one option is there, sir. Like try to eliminate the number of options. Then you will get the answers easily. Just I saw that these two are the long shunt, so here only one option is there. No need to go to all. No need to go to all. Of course, if the any, like here 3 and 2 is there, for example here 2 and 3 or anywhere 2 and 3, anywhere 2 and 3, now we have to go for checking of the polarity, whatever. Here we want 1 mark. Don't try to get the knowledge from the question paper, guys. Don't waste your time. The time is very valuable. The time is very valuable. Yes or no? Of course, you can go through that the given Q is the 3 and R is the 2, Q is the 3. This is cumulative compound they given. This is cumulative compound they given because see here the current will flow like this, plus 2 minus. Here also the current will flow plus 2 minus. Yes, we can get easily. But why we have to waste our time? This is very valuable time, right? So you can get the answer easily, guys. Don't waste your time, Q. Next, let's go for next question. Yeah, the power output of. Really, this is also, I told you in our class, 101% they will ask you question from power equations, and even that the power load angle curve I explained you clearly. The power load angle curve here, this is maximum at 90 degrees, this is maximum at 45 degrees. In between, the total power developed by the machine will be maximum. I given you 60 to 70, greater than 60, around less than 70. 60 to 70. The 60 is the wrong answer, sir. Greater than 60, less than 70, in that range. 60 is the wrong answer. Slightly greater than 90. 90 wrong answer. Slightly less than 90 is 100% correct answer here. Slightly less than 90 is 100%. Okay, slightly less than 90 is 100%. So this is 100% correct answer. Slightly less than 90 degrees, the load angle of around 60 to 70 degrees, we can get the maximum power. I given you the electromagnetic power will be maximum at 90 degrees, the reluctance power maximum at 45 degrees, the total power developed by the machine in between, the what is the stability maximum at 30 to 40 degrees. In cylindrical machine, maximum power will be occurs at 90 degrees. Slightly less than 90 degrees is the 100% correct answer, guys. Right, very good. Transformer excited from voltage source will draw a no load current. I given you that generally when the no load current is a peaky wave, when the no load current is a peaky wave, then our EMF is sinusoidal. Why it is getting peaky wave? When we are giving sinusoidal, but due to this third harmonics, actually, due to this third harmonics, this will be added here. When that is added here, the peak values will come. Because of the third harmonics, it will be, because of the third harmonics, it comprises the fundamental frequency same as the voltage source, and peaking third harmonics will be there. So this is a 65th question is option B is 100% correct answer. If you have, actually you have to imagine these diagrams in your exam. Yes Ramesh, yes, very good. And what about next? Yeah, this is also silly questions, sir, actually. This is also very easy questions, sir, actually. What they asked, the full load voltage regulation of a power transformer is 0. Where we can get 0, sir? I draw this one. This is 0 at near to 0.9 actually. 0.9 actually. Yes or no, guys? This will be, the voltage regulation will be 0 at nearly 0.9 to 0.95 leading, sir. Actually, I given you. Okay, so unity and leading. How, sir? How we can get 0 power factor at unity? That is wrong. 0 voltage regulation at unity. This is wrong. Next, 0 and leading. What is that? Full load voltage regulation of a power transformer is 0 when the power factor of the load is near to. The power factor of the load is near to. Leading is the correct answer. Leading is the correct answer. But which we have to consider here? So unity is the wrong answer. So we have to consider here this B. We have to consider this B. There is no possibility. There is no possibility in lagging. Of course, in leading, but unity is the wrong answer. Unity is the wrong answer. Yes. Let's go for next. Let's go for next. Yeah, this is also really nice question. This is also really nice question. What they asked? A 6-pole lap wound DC armature 720 conductors draws 50 amperes from the mains. Its armature reaction per pole. Armature reaction per pole. Armature ampere turns per pole they has to ask actually. Armature ampere turns per pole they has to ask. Ampere nothing but IA upon A. What is the current in each parallel path? Ampere turns nothing but number of conductors upon 2, because if you have 100 conductors, we can make 50 turns. This is per pole value nothing but divided by P. So what is the answer? IA, what is armature current? They given 50 out of parallel paths 60, number of conductors 720 upon 2 multiplied with 6. 6 6 the 36, 36 2 the 72. 500 is the answer. 500 is the answer. This is wrong answer. This is wrong answer. 500 ampere turns per 100 ampere turns peak value. Sinusoidal in wave shape or triangular in wave shape? Which is correct answer, sir? Generally, in our DC machine, the armature MMF is the triangular. This is MMF, sir. This is MMF. Ampere turns. The MMF is the triangular. Of course, the armature flux is the saddle type. Saddle type. So, triangular wave shape is 100% correct answer, guys. You can get the answer easily. Yes? What about remaining people? Remaining people not giving the response? Yes, sir. Next. The induction motor. The rotor field with respect to stator field. Rotor field with respect to stator. I given you like a diagram. When three-phase AC supply given, the stator magnetic field will be produced, which rotates in clockwise direction. But the stator is the zero speed. Due to mutual induction, the magnetic field, the rotating magnetic field will be produced in the rotor, which rotates in clockwise direction with synchronous speed. Initially, our stator magnetic field also rotates in clockwise direction with synchronous speed. But they asked in induction motor, the rotor field runs with respect to stator. With respect to stator, this is rotating at synchronous speed. So synchronous speed, slip speed, synchronous speed is 100% correct answer. In the same direction as the stator field, in the opposite direction as the, both are in same direction, right? Both are in same direction, right? Really, this is answer. Really very easy questions are there, sir. But you are afraid of which are less questions are there, which are somewhat difficult. And what you not practiced, like analog signals. Is there anyone not practiced? They felt bad. But who prepared whatever the signals and systems and whatever control systems, power electronics and machines and power systems, really appropriate questions are there. Really appropriate questions are there. Right, sir? Right, sir? Yes? Next, where I have a question, sir? Where I have a questions next? I think my questions completed. This is yeah, is completed. One question is there that in induction machine, one question is there, right? 1440 they given. They asked that the rotor frequency. They asked that the rotor frequency. Where is that question? Where is that question? I didn't find here. I think somewhere that question somewhere it missed somewhere. Here it has to be there. One question there. Yeah, is there. Actually, this is also not in clear view. What they given, sir? What they given? A 4-pole 50 heads. 4-pole 50 heads, which is rotating at 1440 RPM, sir. This is my induction motor. What is the rotor frequency? They asked. Okay. Yes, Uday. Direct bits, sir. So generally 4-pole 50 Hz nothing but the synchronous speed is 1500. It is rotating. Actually, even for diploma candidates, even for JLM candidates, I given you by fingertips these questions. Don't use pen. I told you that in your class. Don't use pen. Just think it. 1500, 1440, 60 RPM is the slip speed. 60 RPM nothing but for 1% 15. 60 RPM nothing but 4% is the slip. Don't try to calculate 1500 minus 1440 upon 1500. 60 out of, why you are wasting your time? 60 RPM is the slip speed. By seeing the question you can get the answer. If it is slipped 15 RPM 1%, 30 RPM 2%, 60 RPM 4%, my slip is the 4%. So what is my rotor speed?
The rotor speed, you know very well, Fr is equals to S times of the Fs, slip times of the Fs. What is the slip? Is the 4%. The 4% of 50. The 4% of 50, 4 out of 100 multiplied with 51s, 52s. This is the 2 edges is the answer. 2 edges is the answer. Let's see, sir, how easy questions are there. Sir, this question paper solutions very important for Telangana NPTCL candidates who are watching. Try to utilize. Even yesterday I told you that for KPTCL AE candidates, the questions will repeat from JE question paper. The concepts will repeat from JE question paper. I told you yesterday in the same this time. Exactly, they given 2 questions. Of course, one question is easy, but next question is really very difficult. If you saw my question paper explanation yesterday, you will get 2 marks easily. Within 1 second, you will get 2 marks, right? So, like who are preparing for NPDCL, Telangana, and who are preparing for Mahatransco, etc. This question paper is very important, sir. What we are solving here, you can learn how we can approach the question. The way of approaching is you can learn from this. Yes or no, guys? Yes or no? So generally, really, I am also I felt very happy because every question in the electrical machine is easy. But I expected around 20 questions from electrical machines, but they not reached up to that mark. They asked many questions from signals. They asked many questions there. They covered there. Okay. Depends on rotor frequency, no hysteresis and no eddy current losses. Yes, sir, no hysteresis and no eddy current losses. Because the rotor frequency very much less, that's why no losses, no core losses. We neglected, is there, but we neglected. Okay, so like that. So once go through who are preparing for next electrical exams, just once go through this one, really you can get a best knowledge, really. Some questions will may repeat also. Okay, guys. So I hope everyone written well. Yeah, Uday. Thank you very much, Uday. Here we are like our Sampath sir. It's me and our Kanakaya sir, communications and signals, and our legend of electrical Ramana sir. We are really bounded to serve you electrical peoples, guys. Really, we give you my complete efforts, guys. We give you my complete efforts, guys, in order to get the good rank for your exams. Really, I hope we given the best knowledge for you people. We given the up to mark what you required, more than that even. Yes, I hope most of the people will get the job from this. This is SAIMEDHA. This is Ramana sir's SAIMEDHA, and this is you people's SAIMEDHA. Not only Ramana sir's. This is the SAIMEDHA of Karnataka people who written the exam. This is the SAIMEDHA of Tamil people. This is the SAIMEDHA of Mahatransco Genco who are preparing. This is the SAIMEDHA of course, in Telangana and AP, in our Tirupathi, in our Vijayawada, in our Vizag, and in our Hyderabad, Dilsukhnagar. The Ramana sir and myself, Rashtrigar sir, will be there only in Dilsukhnagar, guys. Some people are calling, sir, where are your coaching centers? In our Hyderabad, only in Dilsukhnagar. Remember that point. But we have in Sheshadripuram in Bangalore, Dwaraka Nagar in Vizag, Tirupati in Bhavani Nagar, and Ben Circle, near to Ben Circle in Vijayawada, and even in Chennai. We have many branches, but in Hyderabad we have only one, that is in Dilsukhnagar. I will be there maximum. Yes, whatever who are preparing for. Yeah, Ramesh, it will be soon, Ramesh. It will be soon. Soon. Mostly within few days, you will get Genco. Before that, you will get assistant executive engineer. Before that, you will get polytechnic lecturers. For Telangana people, really, we have a good opportunities upfront. Guys, try to utilize. We will here to give you Ramana sir. Really, no need to explain about Ramana sir. Really, that experience will help you. Of course, I don't have any experience, less experience comparatively, but I will try 101% to give the maximum knowledge. I will try maximum efforts. I will try to put maximum efforts. Try to give maximum, whatever I can help you in all the ways. So, for more details, try to subscribe our channel and please share our channel. And what are the expected cutoff for this KPTCL AE? The question paper is really good, but most of the people getting the wrong answers because of that fear, which is negative marking, because of that fear. So mostly in open category, it may be around 50, 45 plus, because of less vacancies are there. 45 to 50 it may be open category. Open category it may be around 45 plus, sir. Yeah, Ramesh is there in our SAIMEDHA Gate. In our mobile app, SAIMEDHA Gate mobile app, you can find. In SAIMEDHA Gate mobile app, you can find, sir. Once go to Google Play Store. In that, search that SAIMEDHA. SAIMEDHA Gate. SAIMEDHA Gate. For BE aspirants, we have a SAIMEDHA Gate app. For JE, nothing but sub-engineering aspirants, we have a SAIMEDHA ESET app. For ITI aspirants, we have a SAIMEDHA JLM app. SAIMEDHA JLM, SAIMEDHA ESET, SAIMEDHA Gate. These are our apps, sir. Don't go for other. Many people are doing mistakes. Okay, so these are, if you have any doubts, please feel free to contact our number, the well-known number. Yes or no, guys? Our SAIMEDHA number 949494941234, guys. 949494941234. What I told you in your classroom, don't use the pen. Here also, don't use the pen. Just think it. Just remember it. 9494941234. Easy to remember. Yes, our SAIMEDHA, right? Our SAIMEDHA. Thank you, Ramesh. Thanks for everyone. Please share this video to all your friends, because this is very useful, guys, for even Telangana who are going to write all the exams. This will gives you much advantage. And for more information, I hope everyone already subscribed. Is there anyone not subscribed up to now? Please try to subscribe and please share this video to all. And thanks for your abundant support towards the SAIMEDHA Dilsukhnagar. Really very thankful to all you people. We are here to help you, to give you good knowledge, guys. Please support us. Right? Thank you very much, guys. Thank you very much, guys.